Hello, my name is Adrian BQ. I'm head of innovation of Airbus Cybersecurity, and today I'm introducing SeCoIIA project for secure collaborative intelligent industrial assets. This project has been awarded by European Commission under H2020 ICT aid for security and resilience for collaborative manufacturing environments. The mission of this project is to enhance security and safety for collaborative manufacturing through the digital transition, and namely in the direction towards Industry 4.0 concept. The application sectors are aerospace manufacturing, automotive manufacturing, and naval system manufacturing. So three subsectors of transportation manufacturing sector. This project embeds three users with their factories, facilities, and use cases. It involves a comprehensive approach of manufacturing collaboration schemes, and that means at each layer of the collaboration, namely from machine to machine, from machine to human, from human to human, and between organizations. And also, it includes consideration both for the security and the safety dimensions, in particular because we are addressing safety critical systems that have actions in the physical space and potentially damages in case of attacks. The project duration is 30 months, and we are in January 21, meaning that we are already, we have achieved 1 year of execution of this project yet. The consortium includes Airbus as coordinator, a large enterprise, of course. Airbus is acting as aerospace manufacturing use case provider, but also through Airbus Cybersecurity as developer of the modeling and simulation platform for security training. Continental is acting also as end user, namely for automotive sector, and they are leading the demonstration in this field. Naval Group is leading the demonstration for naval system manufacturing, and they are also in charge of requirements collection. Airbus Cybersecurity Germany is acting as specialist of OT security. They provide the collaborative OT SOC capacity. ISEP is acting as specialist of artificial intelligence. They are delivering the cognitive AI capacity and also in lead of impact management in this project. Fraunhofer ISEC is the specialist of hardware security and also involves specialists of adversarial AI, namely leading the adversarial capacity and also some of the information security activities. VTT is going to be the specialist of access control and encryption. They will lead a capacity named fine-grained access control and encryption in the project. KU11 is the specialist of legal and ethics. They will be in charge of accountability framework delivery. And Systemix, then research center in France, will provide platforms for testing, integration, and also architecture work. Systrade is an SME from Portugal. They deliver ERP and SCADA software, and they will be the cloud manufacturing service provider in this project. Robotics is the specialist of collaborative robotics, a small SME in Spain. They will deliver the human-machine collaboration capacity in this project. And Forescout is a Dutch company, specialist of OT monitoring. They will develop an OT intrusion detection system. When we look at the collaborative manufacturing ecosystem from an Industry 4.0 perspective, we see that we have a combination of existing and novel process flows and information flows. And in particular, the information flows, they grow tremendously today from point to point, but more and more in a cloudified approach. So with the emergence of cloud service providers, initially only for the IT aspects, but more and more also for the operational technology supporting physical processes. And what we have to consider here in the attack landscape is that we have to protect physical assets and also digital assets. And namely, the growing use of digital twins offers both an opportunity and a threat from a cybersecurity perspective. We intend in this project to use digital twins also as an asset for cybersecurity. I will explain that a bit further on, but essentially what is important here is that we are dealing with more connected and more intelligent assets, and we are also dealing with more connected and more intelligent products, in our case, transportation systems in general, that also remain connected and have their digital twin somewhere in the landscape throughout their life cycle. Now, what we mean by multiple levels of collaboration is essentially including within each organization and between organization, the collaboration of assets and humans. And from asset to asset, we have this collaboration machine to machine that is a growing dimension when we consider the greater ability of machines to make own decision and the developments also of communication interfaces between them. This is driven by industrial IoT and embedded AI developments. Then we consider the relation between machines and humans, which is extremely critical and very sector dependent. And we consider also the relation between humans, traditionally that is more supported by traditional IT systems or cloudified systems. This relation expands beyond the factory towards organization to organization collaboration that we have here on the right, that covers all three layers, essentially. Now, the aerospace use case in this project is proposed by Airbus Defence and Space factories of Tabladas, San Pablo, and Cadiz in Spain. They deliver military aircraft. The use case is about industrial Internet of Things, and it involves a real-time data collection on three different assets named RoboShape, Autoclave, and Gap guns. There are different assets. Some are fixed, some are mobile, some are hand tools, and so it requires both wired and wireless security. The interest of this use case is that it will enable, through AI analytics, to propose process optimization and process monitoring and control upgrades. Now, the misuse case that we want to address among different attack possibilities, we want to consider insider threat in particular, because we will have more automated systems and potentially angry workers or also untrusted contractors involved in shop floor activities. And we also want to address adversarial machine learning, as we will now make decisions based on AI analytics. And what happens if the AI is perverted by a skilled attacker? This is a scenario we want to consider. In the automotive use case, we work with Continental Production Plant of Frankfurt. They are involved in a very large network of suppliers and OEMs exchanging crypto materials. Modern cars have a greater number of ECUs that need to be exchanged together with secrets. And in a point-to-point communication, these secrets expand widely, and there is no guarantee of security of the overall exchange. And also, there's a very large heterogeneity of technology that is hard to support. So the idea is to unify crypto exchange and to set up a scalable multi-cloud infrastructure. Now, the misuse case we will consider in this context is a Byzantine fault hack. Potentially going through first a man-in-the-middle attack, and then expanding through different cloud nodes to tear down the whole complex multi-cloud infra. The maritime use case is brought by Naval Group Factory of Lorient. And it's about enabling third-party maintenance, namely remote maintenance and, if possible, predictive maintenance. These factories are very, very critical, very sensitive from a defense perspective. And up to now, they have been completely isolated from the world for security reasons. But for productivity reasons, it will be worthwhile to enable third-party maintenance and near real-time response to potentially safety or manufacturing issues. And that is what we will enable with this project. And in order to protect this new open system, to protect it from typically network attacks, we will address a ransomware attack scenario, running through different approaches. One is from insertion of a corrupted devices, and one is from the network. And of course, by enabling third-party maintenance, we also have a consideration for the risk of attack through the network. The robotics use case, that is a cross-sector use case, could be applied in either of the previously mentioned sectors. Essentially, we are dealing with autonomous mobile robots that can achieve some logistics or inventory tasks. They potentially will solve issues of lone worker protection, enable continuous production, even in the lack of personnel in factory environment. And they have this ability to learn by demonstration, which makes them much more flexible than typical pre-programmed robotics. The misuse case is about adversarial machine learning, as essentially the learning by demonstration capacity is fed by AI techniques. There will be considerations both for typical network attacks through wireless connection, and potentially to let's say more advanced attacks on AI algorithm through data poisoning or mistraining. Through the consideration of these three sectors and 4 use cases, we have identified 4 key challenges that need to be addressed equally in all sectors. And to these challenges, we respond with capacities. The first challenge is to identify and prevent threats. And we address this through the development of an industrial cyber edge. This is essentially about preparedness of security and manufacturing personnel. So by training personnel on virtual environments that would reflect the real manufacturing environments, we intend to enhance prevention preparedness, ability to respond to cybersecurity incidents. Then the second key challenge is to create trust and protect infrastructures. This is achieved through the development of secure cloud manufacturing backbone, essentially using access control, encryption, authentication techniques, and network segregation techniques to make sure that they hyper-connected systems are by design more robust to attacks. And as not all attacks can be prevented, we also need to enforce detection and reaction. That will be achieved through the development of a collaborative OT Security Operations Center capacity. Why collaborative? Essentially because we are dealing with collaborative manufacturing. So problems may expand beyond the limits of a single organization, and we need to involve different parties in detection and response. Now, this all would fail if we didn't have proper means of empowering and enforcing the law. That is why we have a specific legal and ethics activity here in this project that will result in the delivery of an accountability framework, namely to address new threats to, for example, AI-enabled industrial assets and potentially support evidence collection in forensics activities. So these capacities will land in the delivery of 16 key capabilities to enforce security of the factory of the future. These key capabilities answer each of the four main challenges: preparedness, information security, process safety, and social liability, across each of the four different collaboration layers, namely organization to organization, human to human, machine to human, and machine to machine. The one in the upper layer here on organization to organization is somehow federating the three layers below. As you see that the collaborative industrial cyber range will include all three dimensions here. The community-based industrial cyber range for human to human, cyber physical security training platform for machine to human collaboration, and a cyber physical security testing platform for machine to machine. If you consider now for the information security challenge, the delivery of a secure collaborative manufacturing backbone, it of course embeds also all the different layers here with fine-grained access control and encryption, smart combined asset and user authentication, and industrial IoT authentication techniques. For process safety, the collaborative OT SOC will include cognitive and emotional behavior analytics, safe and secure collaborative robotics, detection of encrypted traffic. Regarding the social liability challenge, we will deliver an accountability framework for collaborative manufacturing that includes privacy preserving cloud manufacturing techniques, collaborative OT security forensics, and adversarial and robust AI development techniques. You can find exactly the same list of key capabilities here on this view that is more a functional architecture view. So in the middle, the environment we intend to protect. So with this collaborative manufacturing value chain. In the identify and prevent capacity or aspects of preparedness, Then create, trust, and protect, addressed by secure cloud manufacturing techniques. Detection and reaction, supported by collaborative OT SOC. Empowerment and responsabilization, supported by the accountability framework. In terms of project structure, it gives the following. So you have in the middle the 4 key technical work packages just introduced: industrial cybersecurity training and simulation, secure cloud manufacturing, collaborative OT security operations center, and accountability framework. And then you have transversal work packages like coordination, impact management, use case analysis, risk analysis, system requirements, and to finish with testing, integration, validation, and demonstration in live environments. We intend to bring the following impacts from a scientific perspective. We will progress in cyber-physical system modeling, implement physically unclonable function-based IoT authentication, and cognitive and adversarial AI. From a technological perspective, we intend to deliver industrial cyber range, fine-grained access control and encryption, and next-generation OT intrusion detection systems. Operationally, we will deliver OT security trainings. We will provide collaborative cloud manufacturing services and develop a collaborative OT security operations center capacity. From a normative perspective, the main delivery will be this accountability framework for Industry 4.0 that we hope will influence regulation and standards in that field. We will provide baseline security requirements for industrial IoT deployment and security guidelines for human-robot collaboration. Economically speaking, we intend to trigger a positive impact on competitiveness of EU industry, particularly by enabling digitization and more agile production techniques. We also intend to enable the development of new data-driven business models, like the cloud manufacturing service provider business, for example, and to increase resilience of EU economy to cybersecurity threats and to major crises, in particular by enabling, for example, remote operation of the plants in current crisis. We are now in January 21. We have up to now achieved use case definition, risk assessment, system architecture, as well as a preparedness workshop to collect requirements of cyber range users, and information security workshop to collect requirements of the cloud manufacturing backbone users. Some activities ongoing are the construction of the detailed requirements. We are developing now the collaborative OT cyber range, the secure cloud manufacturing techniques, and accountability framework. So development work packages are started. And upcoming is the process safety workshop, which will enable to collect requirements and feedback from typically manufacturing safety personnel. The liability workshop that is more involving the legal sides and the accountability aspects, and the project technical review that's upcoming in February. Thanks a lot. You can find information on our website, and feel free to contact adrian.bq@airbus.com is my email. Thanks a lot. Bye-bye.